Hello everybody and welcome to the Droidcon Italy. I'm Claudio from the Android Subito team. We are proud to be one of the prime sponsors of the event. We are waiting for you to join our speech and our virtual stand. Thank you so much and enjoy the conference.
Hi guys, I think maybe we can start. Okay, just wait a minute because we was planned to 10 at 10.
Okay, you can start. Don't worry about that.
Okay. Thank you so much. Okay, let's start with our talk. Again, hello everybody, and thanks to attend our talk. Today we are glad to present to you our new library called Esito. Now let's take a quick look to what we are going to see today. So first of all, we are going to do a brief walk through the async history in Android. After that, we are going to present to you the Esito library, and we are going to see also some practical examples about the usage. And we will do a brief benchmark of our solution versus other existing solution. And at the end, conclusion and references. So every day, each developer have to deal with asynchronous programming issue. Maybe, I don't know, if you have to do a network call or maybe a DB operation, stuff like that. If you try to think to the simplest solution that we can achieve without too much effort, maybe you can think about the callback. What are the callbacks? Callbacks are the simple idea to pass one or more function as parameter to another function and invoke this function when it is needed. So let's try to keep a little example. This interface, in this case, a user repository interface, provide this contract with this method, the get user info method, which accept an ID for this example, the user ID, and the return a type of user info. Now we have the function load user info, which have to invoke this method from the repository. As you can see from the signature, we have the first parameter, which is obviously the ID of the user, and we have two other parameters, which are two functions. First one, the onSuccess function, which accepts as input parameter the user info, and the other one, the onFailure function, which accepts as input parameter trouble. So trying to do a little implementation of this method, we have to put at the first line a try-catch block, because we want to do our execution of the call to the repository. For example, we want to catch if there are some exceptions. If there is no exception invoking this method, we get the user info and we can invoke the callback with the value retrieved. While if we catch the exception, we have to invoke the onFailure callback with the throwable inside. So we want to do a little list of pros and cons about callback. So starting from the pros, we can say that they are really easy to use. And also you don't need other dependency to use them. Also, they are ready to use without any prior knowledge, because you are using just the basic of your language, in this case, Kotlin. And also keep in mind that callbacks are a concept, not a structure. So you can apply this concept to every language. Which are the cons for the callbacks? Well, of course, you heard about the risk to create a callback hell. And also, as you can see in the example before, we have a poor error handling because we need to put the execution inside the try-catch block. Also, callbacks are not composable, and you don't know in which thread the callback is invoked, because for the example above, you can show that we write all the code, but we didn't specify in any case in which thread it will be executed. So another step in the asynchronous programming was the introduction some years ago of Rx. Well, Rx is a new word. I try to give you a little description, just 2 words. Well, we can say that Rx is an extension of the observer pattern to support the sequences of data. Now, let's see the example above with the observable solution. The interface looks similar, but this time in this example, we return from the getUserInfo function an observable of user-info. Passing to the implementation of the loadUserInfo function, now we see that, first of all, we invoke the method from the repository, and here we are creating the chain starting from our observable. Now, on the observable, often you have a lot of operator for a lot of function also. For example, we have some function like subscribe on. Subscribe on means that you are going to execute on a specific thread. In this case, we are choosing a background thread. While another function like observe on says that you are going to observe the result in a thread which is again different. In this case, we are choosing the Android main thread because maybe you want to do some stuff with the UI with the result of our execution. Also, there are some functions like subscribe by, which provide you the side effect to invoke on the on success and on the on error situation. Like the callback before, we have the user info value on the on success and the on error the throwable when there is the error situation. Again, which are the pros about Rx? As you saw before, the code is quite simple to read because it's like a clean linear path to read. Thread managing is easy because also in the example before, you saw that we are moving execution between thread in a single statement. And now Rx is composable because with Rx, you are able to compose different observable sources. And Rx also is a concept, and you can build by yourself. You can create by yourself your Rx library, but you can use also existing one like Rx Java or Rx Kotlin. And these libraries are really rich of operators. Which are the cons about Rx? Well, of course, the Rx is an ugly learning curve because if you are starting from scratch with this concept, you have to study a lot of hours and understand how it works. And also, if you are using this library, you have to understand how the operator works. Also, reactive is hard to mix reactive and non-reactive code because often you start to use Rx in a few pieces of code, and after you try to apply a reactive pattern all over the project. It's quite hard to debug with Rx, and mainly Rx is not binded to Android life cycle. Because you have to take account if the activity, for example, or the fragment is still alive, or maybe you can lead to some memory leak. Well, the first step that we are going to see is another milestone in our work, and it is they are the coroutine. Coroutine is an evolution after some year of a big evolution from Kotlin, is another step of the Kotlin path. Well, the example above with using the coroutines now is the repository, as you can see, is quite the same, but this time, instead of return clearly unobservable, we are using a suspendable function with the keyword suspend. Trying to implement the fun load user info, we are going to see that, first of all, we need a scope where to launch this coroutine. In this case, we are using the view model scope to launch our coroutine. So inside this coroutine, we are going to do the same stuff we was doing on the callback. We are going to write a try catch block. Inside this try catch, we are going to invoke the repository, and if this function is successful, you can do some stuff with your happy path. While if we catch some exception, you can do whatever you want with the on error situation. Again, pro and cons about coroutine. So coroutine are easy to get started, not too much stuff to know about that. And like the RX solution, we can say that coroutine are easy to read, because in this case, we are talking about some imperative code. You read the single statement and you know what is happening on your program. So it is quite a good solution. And also a big improvement brought by coroutine is the structured concurrency. Well, 2 words about this. What does it mean, structured concurrency? The structured concurrency ensure that your coroutine, each coroutine, will be launched in a specific scope. So in this way, you are sure that each coroutine has a delimited lifetime, and so you avoid the memory leak. And also, coroutine are highly integrated with the Android component. In the example above, you saw that we launch our coroutine inside a view model scope. So it is binded to lifetime, to life cycle of this of the fragment or the activity, for example. So when it is destroyed, also your coroutine will be cancelled. Well, cons for coroutine, error handling. Like we say in the callback situation, we don't like a lot the try catch statement to catch if there are some exception and there are some error. So this is not a really good point. And other cons, we are not able to find any major cons about using coroutine, because we think that coroutine is a great solution to work with the async function. And the only issue is what we said before about the error handling. Also because it can lead to a strange and unaccepted situation. For example, we provide a little example about that. So suppose we have the main function. Inside, we create a coroutine scope where we launch our coroutine. As we saw before, we do all the stuff inside the try catch block. At this time, inside the try catch, we launch another coroutine that only throws an exception. We catch the exception, print some stuff when we catch the exception. And if you take a quick look to this piece of code, maybe you can think that the block of try catch will catch the exception. But in real, what is happening here is that the inner coroutine launched doesn't catch the runtime exception itself. So it fails, and we say that completes exceptionally. It causes a job cancellation. And indifferent with the standard programming, the exception is not rethrown. but the job cancellation is propagated to the job hierarchy. So we have the parent coroutine will be cancelled when the inner coroutine is cancelled. So this can lead to unexpected situation, or maybe also we can lead to the crash of our application. So our solution, our library, try to resolve the situation to handle the error with the try-catch block.
And that's why we built Esito. But what is Esito? Well, Esito, at its core, it's mainly a C class, a construct provided by the Kotlin programming language that is allowing us to close our domain. So here we are using two generic parameters, foo that will stand for value and in that will stand for error. We have just two possible implementations of result. One is called success, and it's a simple data holder that will hold a value of type v. Otherwise, the other possible implementation is failure, that is again a data holder just for the error type. So in this case, E. But let's see how we can create some results before using them. So if we already have somehow the result of our computation, so the value or the error, we can just invoke a factory method on a companion object. So we have one for create a success result, one to create a failure result. In other scenarios, we are just invoking maybe an external library or our code that is throwing exception, or even the standard library methods that we know that are throwing exception. In these cases, we can just wrap that computation that we know will throw an exception inside a run catching method. So the run catching method is setting a block. It will try to invoke that block. If no exception are thrown, the result of that block is put inside a result instance. Otherwise, the throwable will be catched and put inside a failure. The important aspect of this is that we are not rethrowing the exception. We are just wrapping it, so we are using the throwable type just to model the data inside a failure. Let's see how we can use this method. Yeah, for example, we want to build a safer version of pass int. So given an input string, we want to pass it, but we know that this computation could fail because not every string is an integer. So we can wrap the string.int method provided by the Kotlin standard library that we know will throw an exception inside our catching method. We are not rethrowing exception. We are just using that as an error type for our result. So the signature will return a result of type int or throwable. Let's see how we can use this method. If we pass some valid input, we are getting back a success. And this time the value is an integer. Otherwise, if we pass an invalid input, we will get back a failure. And again, here we are not throwing that exception. We are just using the number format exception as type. So we saw how we can create result, but probably we want also to use them sooner or later. So one method that is allowing us to use results is fold. Fold is used to extract the data inside the result. As you can see in the signature, the return type now is error. It's not a result anymore. And to calculate that error, we are forced to pass from outside two functions. One will handle the success case, so we'll handle a foo. The other one will handle a failure case, so we'll handle a p. The implementation is pretty simple because we can pattern match the instance type. So in case of success, we have a v. We have a function from v to r. We can just invoke it. Otherwise, we have an e. We can invoke the function from e to r and get an error back. So let's see how we can use the fold operator. Suppose that we have this method, the fetch latest news, that is in a real implementation probably fetching some data from some APIs, from external services. In this implementation, for simplicity, in the slide, we are just passing a Boolean, and we are forcing the return type to be a success or a failure. In case of success, we are returning either Droidcon Italy slide news, otherwise a fake runtime exception. This method, the fetch latest news, is probably exposed somehow by an use case in our domain, And what we need at presentation layer is a string representation of that, because we need to show it to the user. So to pass from a result to a string, we can use the fold operator. And fold is forcing us to get data in a string data, but in both cases. So in case of success, we are getting the headline and we are just capitalize it. Otherwise, for this example, it's fine to just get the message inside the exception. So let's try to invoke these methods. If we pass through, we're getting, of course, a string because we are folding the result and the first letter is capitalized. Otherwise, again, we are getting a string because we need to show it to the user. And in this case, we are showing the message inside the exception. Fold is probably the operator you're going to use the most for extracting data from a result, but it's not the only option that you have. For example, you can use the get or the fold when you're fine with a default value provided on the client side. So you are fetching the same result with the fetch related news, and then you are providing a default value with get or default. Here, the return type is new. If you're fine with nullable values instead, and you like to use the nullable operators from now on, you can use the get or null operator on the fetch related news. So the fetch related news is returning a result as always. You are just ignoring the error here. We saw how we can create results, how as last operator usually you can fold it to get the data back. Probably in the meantime, you also need to transform somehow the data. So the first operator we are seeing here is called map. You can map a result of type V, E, to get back another result where the error is fixed, is still E, but their success type is changed from V to R. And to do so, we are setting a lambda from outside. The implementation is pretty simple because again, we're using a C class. So in case of success, we get the back, we have the V, we map it to R, and we put it inside our success. Otherwise, we are just propagating the failure. Similar operator allowing us to change the error type instead is the map error. So if we have a look at the signature, again, we are invoking for result E1 this time, and we are changing the return type to result E2. Implementation simple because we are propagating the success type and we are transforming the failure type. So let's see an example. Let's say that we are modeling our items and their condition with an enum class. So items could be new or used, and in this case, we are coding the description on the client side. We are also modeling some errors, and for this use case, we just need to handle the network or all the other errors as unknown. We have this method that is returning a condition for a given item ID. So you provide an item ID, you're getting that this condition or a result because this could fail. But what we need is not the actual world condition, just the string representation of this condition. So we can map this result using the it.description to get the description, and we are changing, so in this case, the success part. If in other scenarios, we need to change instead the error type, we can use the map error. And again, here we're starting the description of the error this time. Sometimes we also need to perform some side effects like assigning to a variable or logging or writing to file, whatever we like. And to do so, we are providing two operators. One is called onSuccess. And if we have a look at the signature, the input result is of type VE, and also the output result, because here we are not allowed to change it. We are just having a look, let's say, to the inner value. So we are setting a lambda from outside. From the implementation, we are just checking the instance type. And if it's fine, we are providing a look, let's say, to the value. So we are invoking that function. Similar, we have the onFailure operator. The implementation is, again, similar because we are checking the instance type and invoking the lambda. Let's put stuff in concrete. So let's see an example also for side effects. Let's say we want to build a simple cache for item conditions. So the item ID, the string, will be the key, and the condition will be the value of the cache, because probably we don't want to fetch an external service every time. So we're invoking the same getItem condition we saw in the previous slide. This time, if is a success, so using the onSuccess operator, we have in scope both the ID and the condition, so we can store in the cache. Otherwise, we just logging the exception for further investigation later. Another kind of operator is the flatMap, that is allowing us to chain multiple computations because maybe we have several methods returning result because each computation could fail and we want to chain them. If we have a look at the signature method is defined for result UE, we are returning another result RE, so we can think it's pretty similar to the map because we are changing the success type, but here the function that we are accepting from outside is also providing the result itself. So the implementation is even simpler because we just need to pattern match. If it's a success, we just need to invoke the function provided from outside. Otherwise, again, we are propagating the failure. Let's revisit the previous example. In this case, we don't want to code the description string in the client because we want to fetch it from outside. Probably, I don't know, we want to A/B test it or get a different representation over time. So we are fetching it from an external service. It's not in the condition class anymore. We still have a method that is returning a result of condition error given the string ID. Now we have also an additional method that, given the condition, is returning its representation, probably hitting another endpoint. What we still want is a result of string error. So we are getting the result of condition error with the first method. Then we have a condition. We can flatMap, and we have a condition now for mapping, and we can pass the condition to the second method. So we are actually chaining two computation to just spend computation, returning result, and the whole computation is now returning a result of type string error. Esito is also shipping some additional modules. The first one is called async. You can import it if you want. So let's see the first method. We have several generic parameters. So let's see one by one. We have v1, v2, and v3 because this zip method is for result of type v1, as v1 is the success type. We are also passing another result that v2 is the success type, and we are returning another result where v3 is the success type. While the error is fixed, is always the same. To merge v1 and v2, because we need to provide a v3 as output success for the result, we need a function from outside. So aggregating data v1 and v2 into v3. Let's see how we can use it. We can create a result. We can create another result. We can zip them, passing the sum operator as the aggregation function. Now the result is a success of value 42. What's the problem with the previous implementation? Well, nothing is async. Everything is sequential because we need the first result, then the second result, and then we can zip them. What we actually want is another kind of zip function. Again, we're using v1, v2, and v3, and e, same parameters as before, but now we are not taking a result, but a suspend function returning a result. Another suspend function returning another result, and the same, let's say, aggregate function. Now the return type is a suspend function. That could be strange to see the first time, but here our responsibility is just to aggregate functions. We are getting function as input, we are returning a function as output. It's up to the caller to decide if now it's the appropriate time to invoke that. Maybe not, because maybe you want to zip it another time or store it somewhere. So it's not our responsibility to run here the computation. We are just aggregating functions. So we are returning a function that once executed, we retrieve a coroutine scope, and we need that coroutine scope because we need the async coroutine builder to now actually run in parallel the both computation. Then we can await both of them and zip the result. Let's see a concrete example. Suppose that we have a method that, given a user ID, is returning its name, or a field, or an error, because that could fail. Another method is again getting a user ID and is getting a user status, because the user could be like a paid one, a free one, whatever you like, up to your domain. We know that this kind of computation are independent because there is no connection between them. What we need from the UI is an aggregate data of both of them. So what we really need is not two methods getting each one a piece of the data, but a single method getting all the data. But given that we have the two simple methods, aggregate them is pretty simple using the SIP operator, because we can pass a lambda executed the first method, a lambda executed the second method, and as aggregate function here we're using the constructor. This is just syntactic sugar for the constructor. Now here we also want to invoke the suspend function because we want to return a result. Another module that we are shipping is to facilitate testing. So just not throwing exception probably will make your code more testable, but we are also adding some additional methods. Assertive success is doing some instance checking and is providing the value in scope, so you can do your own assertions. Another method is for failures. So again, here we are doing another extension method that is doing some type checking and provide you the error in scope, so you can do your own assertion. The last module we are shipping with Esito is its integration with Retrofit. So the integration is literally one line because you just need to add a core adapter factory, and that's all. Now you can build your instances like you usually do. Let's see how we can use Esito with Retrofit. Well, you are still defining your functions inside your Retrofit interfaces. Now you can use result as a return type directly. And the semantic here is this one. If we are getting a successful response from Retrofit, like 200, okay, then we will build a result success instance with test okay response inside of it. Instead, if we are getting a server error, for example, HTTP 500, so all the not successful HTTP responses, and also the unexpected errors, like, I don't know, you don't have internet connection, or I can't pass this JSON because you're giving me HTML, not JSON. Also, the unexpected will be instances of result failure with a throwable inside of it. If you need additional data, you can wrap the response, inside the result. Response is a class provided by Retrofit, and it's giving you more data, like all the headers, the HTTP status code, the raw response, everything you need. Let's see an example. Suppose that we have the get data that from Retrofit that is returning a result. Now we can fold it. So you are forced to handle the success case and the unfailure. As we said, you have two different kind of errors. One are the server side, so you have to do this check, and now you have everything in scope, for example, the headers or the HTTP status code. Otherwise, you still have to handle the unexpected event. If you don't really like this approach of checking the type, totally makes sense. That's why we are providing also an additional class that is called network error. Network error is a seal class. So again, we can close our domain. The seal class has just two possible implementations. The first one is server error, and it will contain the HTTP status code and the parsed error body, because as default, Retrofit will parse for you the happy path, let's say. Esito is also trying to parse for you the body error. That could be useful because maybe your backend is always returning the same structure for your errors. Like, I don't know, in the JSON you have error and then the string description. If so, we can automatically parse it for you. Another possible implementation is the unexpected error, and here we can't do that much. We are just giving you the cause through code. Let's see how the integration will change if you choose this approach. You are free to choose the approach you like. If you use the network error, you have to use it as error type for your result, giving the type that you are expecting in the body. So, like you are annotating the test OK response with your preferred JSON library, you can annotate the test error response and Esito will try to parse it for you. As always, you can also wrap the response inside the result if you need additional data. Let's see how the usage will change if you choose this approach. If you choose this approach, then get data will use the network error, then you will have in scope an additional fault, forcing you to handle the success with the body, the server error. So here you will get for free the parsed body, the HTTP status code, and you can do whatever you like. And of course, you still have to handle the unexpected error.
Okay, well, as Daniele say, our goal was to provide a library which is light, because at the end we have just one class library. And also we want to provide a modularized solution, because maybe you don't need to bring with you also the retrofit adapter, or we hope you want to bring back also the testing module, for example, but you can decide by yourself what you need for real. Now let's take a quick look to our solution versus some other existing one. Well, of course, you can think about the Kotlin result. The Kotlin result, the problem in this case for the Kotlin result is that only treat the throwable in case of failure, while we are accepting also a custom type for the failure situation. And also, maybe if you are using the Kotlin result, you have not all the operator that we are already providing. Yeah, you can write by yourself, but we are already providing these operators. Another solution, existing solution, is Arrow. Arrow is a great library, but we think that its main scope is to simplify the functional programming paradigm. So if you want to reach our goal, for our thought, it was a little too much for our domain. And also another one was Ethernet, but Ethernet is just for Retrofit. And also we was using the result, our result implementation inside our project when we decided to make a library. And when we was using the result implementation, Ethernet was not yet released. Well, this is the conclusion. I want to leave to you some references. This is the repo where you can find this library. Please mark a star for the repo, and also help us to improve the repository. I want to remind you that in Subito we are hiring Android engineer, a lot of other IT position and non-IT position. So if you want to take some information, ask to our virtual stand or contact us via direct message. And thank you for your attention.